Welcome back, dear friends. We are discussing some concepts of psychrometry. Today, the objective of the lecture is to discuss a very unique process which happens in practical air conditioning applications, namely mixing of two air streams. So, what I mean by mixing, I will draw a schematic to explain you what exactly I am trying to deal with. So, what we are going to study is the psychrometry applied to the mixing process, and the mixing process we will idealize it as an adiabatic process, meaning that there is no heat loss to the surroundings during mixing. That is the meaning of adiabatic mixing process. So what exactly I mean by mixing, and where do you see this mixing process? So in your air conditioning application, let us say that this is your room to be conditioned, and this room is to be conditioned, let us say, and I need to supply some conditioned air for conditioning this room. This room, we said, has to be maintained at certain design conditions, certain comfort conditions, at let us say some temperature T1 dry bulb and T1 dash wet bulb temperature. This is the, let us say, comfort conditions to be maintained inside the room. And let us say that the outside conditions are T2 and T2 dash outside this room. Now in your application of air conditioning, generally when we are talking about central air conditioning, what we do is that we supply this room air back to the conditioning coil. So this is your conditioning coil, this is your AC coil. So what you do is you supply the room air back to the AC coil. So this would be unconditioned. It will come back to the AC coil and it gets conditioned and sent back to the room. So this is called as a recirculated air. And let us say that it is being supplied to this room at certain supply conditions. Yes, okay. Now what generally happens is, when you are talking about central AC system, some of the room air you throw back to the atmosphere and you suck in certain fresh air. So what you do is that some fresh air is taken from the outside and certain room air is thrown out. So partly the room air is circulated and partly you are mixing it with fresh air. So this is a typical process. So let us say that this is at the state 2. This is outside condition. So outside condition, we said that it is at a state 2, and this is the inside condition. So this would be at a state 1. So the mixing problem becomes now that the room air which is at a state 1 is mixed with the fresh air which is at a state 2, and then we are interested in knowing exactly what is the state at the entry to the AC coil. So this is a design problem. So in air conditioning, we are always interested in knowing what is the state of the air entering the AC coil and what is the state of the air which is leaving the AC coil. So an important design problem is what would be the state of the mixed air. Okay, and how do you get this state of the mixed air? If you know the state of the state 1, that is the room air, that is recirculated air, and if you know the state of the fresh air or ventilated air, how to calculate that? That is the objective of today's lecture. So this problem becomes now a mixing problem, wherein I will draw this. Let us say this is your room or recirculated recirculated, and this is your fresh, or it's also called as ventilation air. Okay, and then this is a mixed air which goes to the AC coil. Okay, so as we had named this as state 1, this is the state 2, and this is the state 3. Okay, so how do you solve this problem? So for solving this problem, it's a very simple thing. You write a energy balance and you write a moisture balance. So by writing an energy balance and moisture balance, you get equations which can help you determine the state 3. So how to get state 3? So state 3 can be obtained by writing an energy balance and by writing a moisture balance. Okay, so the energy balance is what? So the energy balance would be M3 H3 is equal to M1 H1 plus M2 H2, where H is the enthalpy, and moisture balance is what? M3 omega 3 is equal to M1 omega 1 plus M2 omega 2. Right? Understood? So how do we get the state 3? What is the state 3 we said? State 3 is the state of the mixed air. You know the state of the room air or recirculated air. You know the state of the fresh air or ventilation air. And we want to determine the state of the mixed air, that is at the state 3. And how do you do that? We do that by writing an energy balance 1, that is M3H3 is equal to M1H1 plus M2H2, and by writing a moisture balance M3 omega 3 is equal to M1 omega 1 plus M2 omega 2. What is omega? Right, omega is the specific humidity. And what is the unit of this? It is basically kgs of water vapor. So you just note that when you are multiplying this kgs of water vapor, and the denominator is kgs of dry air. Okay, then you'll get, if you multiply this kgs of water vapor with kgs of dry air, so omega into m would give you moisture. Okay, if you understood what is omega, then you'll also understand why omega into m is the moisture value of water vapor which is there. Okay, so this I will represent on the psychrometric chart. So psychrometric chart, your outside here is at a state 2 and the inside here is at a state 1, and then we are interested in knowing what is the state 3. Just horizontally, it has to be a horizontal line. We'll draw this. Okay, so let us say this is your state 1 to 2. Okay, so this I'm interested in now knowing what is the state 3. So where would be the position of state 3? Where would be position of state 3 on the psychrometric chart? So this is your state 1, means this is a room here, and this is your outside here or fresh air. Okay, fresh. So if you have more of the fresh air, then your state 3 would shift towards 2, and if you have more of the room air, then your state 3 would shift towards state 1. Okay, so depending upon what is the proportion of mixing outside and room air, your state 3's location would be fixed. So now we have determined what is 2, what is it? State 1, you know state 2 and state 3, and by doing the energy balance, that is M3H3 is equal to M1H1 plus M2H2, you get what is the value of H3. Similarly, by doing the moisture balance, you get the value of omega 3. And from the psychrometric chart, by knowing the value of H3 and by knowing the value of omega 3, we get the representation of state 3. So this is how state 3 is represented on the psychrometric chart. So this is a very important concept, and in the forthcoming videos we will solve these numericals based on adiabatic mixing. I told you that adiabatic mixing is an important case which is happening in the practical life, wherein you are mixing the recirculated air with the ventilation air, and we are interested in knowing what is the state of the mixed air before it enters the cooling coil. Thank you very much. See you in the next video.